All right, number 13 says, this is section, what, 3.3? Is this for you guys? So Foundations Math 20, 3.3. So, 20. It says, two drivers leave their school at the same time and travel on straight roads that diverge at 70 degrees. So diverge means goes away from, and 70 degrees is the angle. So here's the two cars, and here's the angle. So they give you a diagram. It's kind of nice. One driver travels at an average speed of 33 kilometers per hour. Okay, so I'll highlight that. 70 is already given. The speed, okay, average speed of 33 kilometers per hour. The other driver travels at an average speed of 45 kilometers per hour. How far apart will the two drivers be after 45 minutes to the nearest tenth of a kilometer? So there's many layers to this question, for sure. So if you haven't seen a question like this before, it might be a little tricky to kind of manage the time and the speed and the angle and all that. So what I'm going to do is I'm going to set one of these cars the speed of 45. Which one do you think would go 45 if you look carefully at that diagram? Do you think that you'd be able to tell which one's going faster? Or how would you know? Okay, so if these cars have been traveling for the same time, the one that's going faster will have gone farther. Does that make sense? So if you can tell if one of these lines is longer than the other, then that's the faster one. On this screen, it's tough to tell. Can you guys tell if somebody said the red? Does this one look longer? Okay, let's make this the 45. Now this is 45 kilometers per hour, so let's just be careful with this. This one's going to be 33 kilometers per hour, okay? Now the time that's given, we're given a time, is 45 minutes. So what you have to realize is that we have to make sure that in these questions our units line up. That's the way I'll say that usually. Make sure your units line up. So that means that if we're given a time inside this speed of hours and we're given a time over here in minutes, something has to be adjusted so that those times line up, okay? So I'm going to change this 45 minutes to 0.75 hours, okay? So that my time of all of my quantities line up, okay? So now speed, we don't normally talk about speed, but when we talk about speed and time, all right, speed times time equals distance. How do I know that? Well, because kilometers per hour times hours, that's a unit on top and on the bottom of a fraction or a multiplication, so that equals distance. So that's really what we're interested in. We're interested in distances, right? So I need to change this speed into a distance, and this one too, speed into a distance. Okay? So again, there's many layers to this problem. Make sure your units line up. Make sure that in a diagram that speed and time combine to make distance, because we're looking for lengths of lines and distances, right? So that's the second tricky part. So I'm literally going to multiply 33 kilometers per hour times what? Times the time of 0.75 hours. Is that okay? Does that look right? So let's get our calculators out and we'll do that over here. Let's see. So 33 times 0.75. And that gives us 24.75. So that means that in 45 minutes, 0.75 hours, that this car at this speed has gone this many kilometers. So that's what I'm looking for. I don't want the speed there. I want the distance of 24.75. And we'll do the same thing for the other car to find out what its distance is. All right? So we'll change that 33 to a 45. 33.75. Okay, is everyone seeing that? Okay. Now, if you haven't done this question yet, you get to finish it. Okay. I want you to do it. That's the first half. That's the hint there. Now that you have two lengths and a contained angle in a triangle, now you can use the cosine law to find out the distance the cars are apart from each other at this exact time. Okay. So now you use the cosine law to find out this unknown length right here. Okay. All right, so I'll give you 2 minutes to finish that before we move on. All right, for question number 13, this is what you should have. For an answer, you should have about 34.4 kilometers. So you fill in your values. Obviously, we're going to put this question mark squared on one side of the equation, and then cos of 70 is going to go on the other side. And in between, make it look like Pythagoras here, right? So 24.75 squared plus 33.75 squared minus 2 times the length of the sides that you squared here, and then times cos 70. So we evaluate this. You can do this on your calculator. Make sure that you're subtracting, but this is multiplying here. You multiply all this together. So you have this that you add together, and then you subtract all this thing. You should get 1180.238, and then finally you take the square root of both sides to get rid of this squared here. And you should have about 34.4. I think that should agree with, you get that? Good. Okay. Okay, so that's question number 13 there for you.
Oh, no.